Hey, y'all. Welcome to class on this miserable rainy day. Although some of you are probably not in Knoxville, so you might not know that it has been raining cats and dogs. And I was just told there might be or is a flood advisory out. So maybe I can float my car back home. Okay, let me share my screen with y'all. And can people see my screen? Yes, anyone there?
Yes.
Okay, thank you. Okay, so today is day 2 for Python. And what I'm hoping to do today is actually both go over the Python notes, but also have you work definitely the first problem in the homework assignment, the tail problem, and possibly the second problem in the homework assignment. More likely not to get to problem 2. That takes some time, but certainly hope to get through question 1 and also just at least talk a little bit about 2 and what your approach to it should be. So with that, let's go back to the lecture notes. And what we're covering today is data structures in Python and IO in Python. And in particular, with the data structures, we're going to be talking about tuples, lists, sets, DQs, and hash tables. Notably missing from today's discussion is trees. And that is because the native implementation of Python does not have a tree implementation. I believe, I think it's the Py module for Python has a tree implementation, but we're not using that in this course. So these are the basic data structures that you will be using in addition to classes. We will get to classes. So classes next week. So that is next week. And the second thing we're covering today is IO. So how you get input and output from the console and from files. So let's start. And you already have seen lists. So I'm not going to spend a ton of time on lists. I will tell you that my notes are a nice succinct summary of the tutorial. So you can kind of look at my notes and get a feel for what's in the tutorial. I will also tell you that with my notes, you can solve every problem in the homework assignment. You don't need to go Googling. You can to Stack Overflow and the like, but my notes have everything you need to solve the homework problems. So big thing about lists, just remember, they are an array. They are not an actual list. So when you insert at the front of a Python list, it's an order n operation. Again, we don't worry a lot about efficiency with scripting languages, but it's still important that you know that fact. And I'm not going to go over every operation that you can perform on a list, but I think I have captured the most common ones that you do have with a list. Also, one thing though that does catch people, notice that all of these are methods on a list, but there are 2 methods that are not on a list, and that is length and delete. So if I say, let's create a list. Can you all see this at home? I know I'm typing at the bottom of my screen. Can you see that?
Yeah, I can see it.
Okay, great. Okay. So if I say a dot length, again, error message, and that's because it's actually length is the way you get it. The same thing, you might think that because you can say a dot insert 3 100, okay, and it inserted it at 3, you should be able to say a delete 3, syntax error. Instead, you have to say delete a of 3, and that's how it's done. So I think they decided that delete and length were these common operations that they were going to apply to every data structure or every sequence. And so they made them global functions as opposed to methods on the object. So just know that, I guess something to know is that length and delete are global functions rather than methods. So Python does have a collections library that you can, by the way, you can delete slices too, which is very convenient. One thing that I used to show and don't anymore is how easy Python made quicksort. You may remember that when you are shown quicksort, you often see it written in a book with pseudocode like qsort A0 to say pivot and qsort A to say pivot n. And the neat thing about Python, you can actually write it this way. This isn't pseudocode. This is actually a slice. Each of those is slices that you could pass to quicksort, and then you get them back. And I think they're, I forget whether they're pointers or not, but based on whether it's a shallow copy or a deep copy, you either merge it or you already have the sort in place. So this feature, this slice feature of lists is very convenient. It comes up kind of again and again with things. So something good to know. Also, there is a join command that you can use with a list that I'll show you in a moment, which is very helpful. Let's see. So the next thing, sorting, is a very common thing that you do in Python. You'll be doing it on question 2 and 3, I believe, in the homework assignment. So just like Java, you can either do a sort in place with the .sort method or get a copy of the list and then it's sorted with the sorted function. And the sequence, I'm sorry, the sort algorithm is stable. Does anyone know what that means as far as what the sort algorithm used is? See if you remember from 302.
I remember what stable means. I don't remember.
Which algorithms are stable and which aren't? So stable means that it preserves the order of equal elements in the original list. Quicksort is fast but is not stable. Merge sort is stable, and therefore Python uses merge sort. And It sorts in ascending order. If you want to sort in reverse order, you just say reverse equals true as an additional keyword parameter. And there are times when you want to sort tuples or objects. So I need to make a digression. So I'm going to make a short digression, which is that a tuple, instead of it being, it's like a list, but it's immutable, and you use parentheses rather than square brackets. So this, whoops, is a tuple. It is an immutable collection or sequence of values. So unlike a list, I can't change it. If I say A of 2 equals 5, it's going to be unhappy. Object does not support item assignment. So we'll get to tuples in a moment. All I want for you to know for the time being is a tuple is like an immutable list. Think of it as a read-only list, and you create it using parentheses rather than square brackets. So coming back to sort, there's frequently times when you want to sort either a list of tuples or a list of objects, where objects is a class of things like what you had, like say a class of people, and they have various attributes. So Python has some functions that allow you to basically indicate what the sort key is. So here, oh, this is actually a little bit different. This one is pre-processing your input. So in this case, it is saying before I sort the list, apply this function string.lower to every item of the list in order to achieve what I want to compare. So here, maybe I just want to compare irregardless of case. So I want to be case insensitive. So before I sort the list, the first thing I do is apply this function to each element of the list. It's done once, and it will return each string as a lowercase. Here's another example. So I'm sorting some tuples, and you can see it's basically a name, a grade, and a score. And I want to sort them in ascending order by score. So here I use key equals, and now I create an anonymous lambda function that returns the last element of student. So this will actually, I guess it was age, not score, but at any rate. So when you sort it, it's now sorted by the age. Okay, and then sorting objects, again, you can use the key. So here it's again applied. So this key is a function. It's applied to every element in the list before the list is actually sorted, and it's done once. So here it is applied to each element of the list, coming up with their age. Now, when you sort it, you'll get the entire object. So in this case, student objects would come back, and it would be a list of objects sorted by the student age. But the important thing is you might be tempted to just write it like this: key equals student2, rather than key equals lambda. And this will get you a type error because key is expecting a function and not a value. Okay, so it expects a function. Another kind of disconcerting thing with Python is it's not real easy to specify primary and secondary sort fields. So if you want to do a primary and a secondary sort, then you would do something like this. You would indicate, in this case, the two fields I'm doing the sort on with the key. And you notice that what I am returning here is a tuple. So it is a immutable list of two values, the student age and the student name. And you would think that I am sorting this by age, and then the secondary sort key is name, and you would be wrong. In fact, what it does is it first sorts, makes one pass and sorts it by student age. It then makes a second pass and sorts it by student.name. So in fact, the primary key is student.name, and the secondary is student.age. So that can be a little bit, take some getting used to, that the order is actually, you start with the least important sort key and work your way up to the most important or primary one. And another thing is, it's not so easy anymore to just say key equals reverse, because it would reverse it for everything. And you may want some of the keys in ascending order and maybe the secondary key in descending order. Actually, that's where you do the sorts. I'm sorry. I may have messed this up. Just a second. I am going to try something. I think I messed that up. I think here it may actually be doing it by age first and then name, that this is the primary and this is the secondary. Let me just.
I'm pretty sure that's how it is there.
Okay. So I'll take it back. Actually, this is the primary and this is the secondary. The problem comes when you want the primary and secondary keys sorted in different directions. And now you can't do it this way anymore, because there's no way to basically say student age ASC, student.name DESC. So instead, with different orders, that's where you have to start by doing the sort on the secondary first and the primary second. Now, a trick is if the secondary is a integer, you can just put a minus sign in front of it. So if I was doing, if this sort right here, sorry. So if I wanted to sort student name and then secondary by age, I could do it that way in reverse. But here, the way I had it, sort first by age and then by student name, and I want to go in descending order or reverse alphabetical order by name, I'm out of luck. I can't just say a minus here. It would be nice, again, if I could, but I can't because it's not a number. So in this case, I would actually have to do two sorts. I would literally have to first do sort it student object using key equals lambda student, and now it would be student.name. And I would have to say something like first pass. And then I could say result equals sort it first pass key equals lambda. I'm sorry, this would be reversed equals true. And then I would say lambda student dot age. So that is not so intuitive, that when they go in different directions, you have to do two separate sorts in order to get the result that you want. Okay. Questions about that? So again, just to reiterate, my first thing was wrong. When you do it like this, it literally, this is student.age is the primary. This is the first secondary. If I add another one, that would be the second secondary and so on. So did mess that one up. Okay. Now, because it is so common to want to access one part of a tuple or certain parts of certain fields in an object, Python has introduced convenience methods that simplify it, and they're in the operator module. So we haven't talked a lot about import, but it's just like Java's import statements in many ways. So here we're importing the items from operator into our namespace. And it has an item getter function that works with tuples. So this is saying that I want to be sorting on the third field in the tuple. This item getter says first sort on the third field and then on the second field. Okay, and interesting. I did this. I know I said before that that sorts, I actually did this. Okay, I'm going to check this again. I know here I'm saying item 2 is the secondary and item 1 is the primary. And I actually ran an example before class, and it really did look like 2 was the secondary and 1 is the primary. So I will verify that and make it absolutely clear which is which. Okay, with attribute getter, that will indicate which fields I want. So here I'm sorting student objects and it's saying sorted on age. Here I'm getting it and it sorts by grade and then by age is the claim. So I'm going to look this up, make sure that this is absolutely what is going on, because if it is, it means this is the secondary and this is the primary. Okay. So you will be using sorting, as I said, on both questions 2 and 3 of the homework assignment. And a common thing that we'll get to is how you sort a hash table, because oftentimes, as you did on the test, the sort needs to be on the value field, not on the key field. So you actually use the hash table to accumulate some counts. You then have to sort on the count field and then print everything out. Okay, we'll show you how to do that in a moment. Okay, so there's some other useful operations on lists that are helpful for big data and data science. They come from actually the field of functional programming. So the first function is called filter. It applies a function to each element of a sequence, and it returns a list or sequence with all elements of the sequence that satisfy this function. So this function returns true, false. As an example, here we have a list of names and salaries, and we want a list of all people who make less than 40,000. So here I create a filter function, and I'm asking, does the person make less than 40,000? So Brad does not, Yifan does not, Smiley does, George does, and James. James should be in this list because James makes less than 10,000. So James should also have been in this list here. This backslash right here says continue the line. Don't try to execute it. Because normally if I just hit return here after this comma, it would try to execute it. So if I am in Python, and I just hit return, actually interesting. Let's see if this works. Well, in this case, it looks like I did not need the continuation, but if you want to be absolutely certain that you don't get into trouble, this backslash says continued on the next line. So now if I have this filter, looks like, just a moment. That's right. You don't need the parentheses there. And I get caught with the old syntax. Okay, so it actually filter returns a filter object, and then you can iterate through that filter object in order to do it. So I'm not sure if that's something that's new to Python 3 or whether that was always the case, but it returns an object that you can then iterate through. Okay, so map is a function that applies a function to each element of a sequence. So here I want to return the cube of the first 10 positive integers. So my function is x cubed, and I'm applying it to this sequence, which is 1 to 10. And I'm guessing I'm going to end up with the same thing, that this is a map object. Yep. So in fact, what I need to do is for I in. That gives me my list of cubes. And then, so you can give it multiple arguments to map. So here I want to add these two vectors pairwise. So now I give it two sequences of equal length. They have to be of equal length, lambda x comma y, add them together, and I should get this result, a sequence with these values. The third one is the reduce function. So it is applied to a sequence pairwise to get a result. So for example, if I want to find the minimum value in a list, I can use the reduce function. So, or if I want to add the numbers of a list, I can use the reduce function. So here, what I am doing is adding pairwise values. So what happens is here, it gives me the first two values, 10 and 20, and that returns 30. Then the next value in the list is given as y, and the sum from the previous operation is given as x. So that would give me 60 now. So now 60 would be given as x, and 40 would be given as y, giving me 100. And finally, 100 would be given as x, and 50 would be given as the y, and I'd get 150. So we'll see if this actually has the same issue of, this should produce a scalar. So what do you mean reduce is not defined? Let's see here. It used to be defined. Only works since 2.6, but I think I'm in 3.9. 3.9, why is that not working?
I'm seeing something that says you have to import it from func_tools.
Really? But I don't have to do that with map or func_tools. So import how? Func like that?
Yeah, that's what that's what this website's saying.
Huh.
And then
so let's see. Yep. Huh. Interesting. Well, I will add that to the notes. So you have to import reduce from func_tools. Thank you.
You're welcome.
Okay. So these are all big things that you do on big data that you might have, for example, sensors that have given you a whole bunch of temperatures. And the temperatures might come from different locations. So they might come, let's say you have a bunch from Knoxville. Maybe they're coming in as a key value pair. So it's Knoxville 50, maybe Memphis 48, maybe another one coming in from Knoxville, and it's 63. And what you want to do perhaps is find the minimum temperature from Knoxville. So the first thing you might do is apply a filter function so that you only get Knoxville. And then you would apply a reduce to get the minimum value. So you can chain these functions when you've got a lot of information coming in from like sensors or other things in order to compute results that you want. So map, reduce, and filter are all frequently used these days in big data. Okay, with reduce, sometimes you want to provide an initial value. So for example, perhaps I didn't want to start this sum from 0. Maybe I wanted to start it from 10. Then I would provide a starting value. Okay, normally you don't need to do that, but if you do want to provide a starting value, you can. Okay, and here, yep, so here is an example of returning a minimum value from a vector. So this is a special form of if then else that was introduced in 2.6. You can't actually say if x less than y, x else y in a lambda function. You have to use this version. So it's specifically this syntax that works, and it returns the minimum value. You can also define a function separately like this, and then just pass the name of the function to it. Okay. So again, these actually functions come from functional languages, and you will see them again when we get to the end of the semester. Okay, so questions about lists. As I said, I'll get back to you on that sorting and exactly what is the primary and the secondary key. Other questions? Okay, so you don't have a stack object in Python, but you don't need one because you just use a list. You use appendix as your push. You use pop as your way to remove something from the stack. However, if you want to use a queue, then there is a collections library, much like the standard template library in C++ or the generics in Java. And you should import a DQ, double-ended queue for that. And it provides efficient operations for appending to the end and popping from the beginning. And the reason you should use the Python provided DQ is that lists are implemented as arrays. So if you try to do a, actually it's a pop from the front of the queue, it will be an order n operation. So the DQ implements it in a way that the pop left is order 1 and the append is order 1. But if you use a list to do your queues, you will end up with order n for your pop operation. So this is actually importing it into into the namespace. It's saying from collections, I just want this one thing imported. So in Java, you would say import collections .dq. But in Python, you say it this way, from collections, import DQ. And that imports only the DQ object. Okay, so that brings us to tuples, which are as I said, an immutable list essentially, so read only. And they're enclosed in parentheses. You don't have to actually enclose them in parentheses. So you can say t equals 369, and it's a tuple. The one thing you have to be careful about is this just looks like the number 4, like you want it in parentheses. So if you want a 1-element tuple, you have to say it like that to indicate that it is a singleton. And one of the cute things about tuples is they provide a useful way of returning multiple values from a function. So here I have a min-max function. And not only does it return the minimum of the two, it also returns the maximum. So if x is less than y, it returns the tuple xy. Otherwise, it returns yx. And here you can see how I unpacked it by just putting min and max on the left side and assigning them the results of that tuple. So you often find it frustrating in many languages that you only can get one return value. Technically, Python is like that you can have only one return value, but you can package those return values into a tuple and thus effectively have multiple return values. Now you might say, why bother with using a tuple when I could just use a list? And the reason is they are more space efficient because with a list, Python over allocates because it knows that it's going to be adding to the array. Remember, lists are not linked lists, they're arrays. So when you create a list in Python, it over allocates. And so tuples are more space efficient. They're also faster to create for exactly the same reason. You know exactly how much space to allocate to them when they're created, whereas when you create a list, you don't. So you have to create a bigger chunk of memory than you think, and you have to be prepared for them to be dynamic. So instantiation is faster for tuples as well. Now the accesses, they're essentially still both arrays, so the access times are the same. Okay, and then dictionaries. You need to get used to using dictionaries. Okay, the reason that they are so prevalent and trees are not even implemented is the following. Hash tables. Order 1 for find, delete, and insert. Trees. Order login for finds, delete, and insert. So trees are slower for all three operations. The only real reason you ever use trees is for range queries, where you have to keep the information in sorted order because sometimes you want all nodes between X and Y. But that doesn't happen very often. Okay, also if you want the final thing to be sorted, you might use a sorted map. But it turns out that generally just using a sort method at the end is faster. Insert into a hash table, dump the hash table into a list and sort. Turns out it's often faster than using a tree. So if you really want something sorted at the end, but you're doing a bunch of inserts, finds, and deletes, it's still often the case that a hash table is faster. So you really only want a tree when you specifically need to be able to do range queries, and that's pretty uncommon. And that's why Python does not implement trees, but has hash tables as a built-in function or built-in table. So it's all pretty straightforward. This is the check to see whether something is in the table. You use key in. Delete is that global function I talked about. Now, here's the important thing is that you often need to be able to get your hands on a sequence of the keys, the values, or the items. So to get a list of the keys, you do tel.keys, and I think these days it may return an iterable object. So let me just check this. Create this object. Okay, so you see it's not exactly a list. Instead it's saying dict keys, dict values, but you should be able to iterate through it. So I should be able to say key in tel.keys, print key, and it works. So what you're basically getting back is an iterable sequence from when you do this. Okay, and the same thing with, let's just make sure that item still works. Yep, so same thing, it gives you back a tuple, it's an iterable list with the key value pairs as tuples. Okay, now if you go back here to the first day, you can also, instead of saying items, you can say iter items, and then you can say K comma V like that, and it provides you a way of iterating through. I don't care which you do, whether you use iter items or whether you use items. Either one is okay with me. Okay, and then sets, they're built in. They're not part of the collections. You just use curly braces, just like a set. You can also create a set from a sequence. You can create a set with an empty set with empty braces, or just by set with nothing. It automatically eliminates duplicates should you create a set with duplicates. So you'd only end up with 9, 3, and 6 here. To test for membership, use in. Add and remove. So why you don't say delete is not consistent, but add and remove are the ways you add and remove elements. They don't return anything. You might think that add return true if it worked and false if the element was already there, but it doesn't. It's neither function returns anything. And then you can union using the pipe operator, intersect them two sets using the AND operator, and do a set difference using set difference. So very nice, it's all built in. Okay, so that's, any questions about data structures? Just a quick review of that. What we have are tuples, which are effectively immutable lists, sets, DQs, which comes from the collections library. So this is the one that's not built in. It comes from the collections library, and hash tables, which are built in. Okay. So then moving on, we'll talk about IO. So I don't recommend trying to get input interactively from standard in using Python. You can do it. So I can say, x equals input, please enter a number. And you see I get a prompt, and it's, I didn't put in, so enter 43. X is a string. So first of all, it doesn't matter that I asked for a number, I got it, but it's still a string. So it automatically prints a prompt. Obviously, I should have put a, but that's generally not the way we want to go about getting our input. But just so you know, you use input prompt and it will print out a prompt string. Obviously, you wouldn't normally execute that in the command interpreter like I did. It'd normally be part of a file. And you get it back as a string. So to convert it to something like an int or a float, you have to use the appropriate function to actually do the conversion. Okay. So more normally, you would simply be in a file and you would be executing a script, and you would want to read lines from standard in. Here's a very easy way to do it. So there is a module called sys, and it has a variable defined called standard in. And as you can see, you can treat standard in just like it is a sequence. So for example, let's put this into a actual file. Okay, so, and we'll create a file and redirect it. So vi read.txt, the quick brown fox jumped over the fence. And we will execute that using redirect. And it didn't like what? Process the line of input. How about we say print line? And it prints it. You'll notice that there are some blank lines here. And that is because when you read the line, it doesn't strip the new line character, and conversely, print by default puts a new line character there. So to get it not to do that, I have to strip the new line character off. So you get the entire line. Okay, so with Java, you had to use scanners to split a line. It's a lot simpler in Python. You just use the split method. So if I wanted to print them out, instead, I could just say my words equals, we'll say line.strip.split. And then we will print the first word on each line. Thank you. So that will print the first word on each line. Did I say words? Oh, thank you. And you can see the fox over fence. So it worked as we thought. So much easier to read a line and split it than in Java. If you just want to, normally you want to strip all leading space, but there is L strip and R strip. Okay, so very simple for reading lines from standard in, just treat it like it's a sequence. Okay, and Python does use line-oriented IO. So that's important.
I have a question.
Mm-hmm. Go ahead.
Could you wrap the where you're getting the input, the stdin, could you wrap that in enumerate to get the line number?
That's interesting. Let's give it a try. For line, let's try for I. See if it just works or whether it gives us a, it looks pretty promising, doesn't it? We'll print I, comma, words. Yes, you can.
Awesome.
Pretty nice, huh? Okay. So it really does operate just like a sequence. Little bit. I don't think you could say print. You can't quite treat it as an array because I don't think it's going to skip ahead to the third thing in standard in. I don't think you could pull this stunt. I don't think you could say print sys.standardin 3. I'm pretty sure that would go down and drain. Let's try it. Yep, that one went down the drain. Oh, no, it didn't. Not yet. Yeah, it went down the drain. So it's not subscriptable. There's limits. Okay. So formatting for output, a lot like printf, except you still use print and you format the string. So what you do, if it's very simple, you just have a string and you justify it in a thing of this width. So for example, 10 dot R justify 5. You see it gives a string back with 3 things. If I say 10 dot left justify in a field of width 10, I get a string. So it returns a string, and you can even center it, which is kind of neat. Center it in a field of 15, and it's centered. Okay. So that works when for very simple formatting. And then I could just print it. So I could say print 10.center 15, and there you go, it's centered. For more complicated formatting, you say dot format. So just like printf, you provide a formatting string, and then you say dot format and provide the variables that you want to print. And inside the formatting string, you have your formatting directives. And the first, so they're in curly braces. The first one refers to the position over here. So just like Java, you get the ability to reuse your arguments if you want. So you specify explicitly what you want. Then a colon is the delimiter between the selection and the formatting. And the formatting is just like in much like in C++. So you have the same types. D is integer, S is string, B is bool, C is character. Little different is if you want left justification, you use a less than sign rather than a minus sign. If you want to center something, you use this little caret. Just like in, so with a float, I could say 8.3 here. So for example, if I want to print a floating point number, so we won't worry about printing just yet. We'll just say 0.3.2f dot format 8. As you see, we got 8.4. If you want, so if these objects are objects like from a class, then you can specify not just the position, but the field you want printed. So here, what I want is 0.weight. If it's a tuple, in addition to specifying the variable that I want selected from the list, I can select the position. This works for either a tuple or a list. So here, x equals 1, 2, 3, 4. And what this 0, 1 does is it says select x and select x1, which happens to be 2. Don't worry about this. This is beyond what I care about. And so being able to get at a specific field name or a position in a tuple or a list is nice. It's not so necessary to have so-called keyword things. Okay, so more specifically, you start with a fill character, so you're allowed to have a fill character at the start of your formatting string. This is all after the colon. Your alignment, which is less than, greater than, or a caret by default, though I think most things end up right aligned. Then a width, dot precision, and the type. So pretty similar to C++. And well, to C actually. Now for opening and closing files, for file IO, you give the file name and the mode, which is R for read, W for write, A for append. This looks very much like C because that's what it was taken from. So a common thing to do is to forget to close a file. So a good habit to get into is using a with statement to open a file, just like in Java, you had a try with resources. In Python, it's a with resources. So when the variable goes out of scope, So when this with statement terminates, then work file will go, I'm sorry, F will go out of scope and it will automatically be closed. Some nice things, read reads the entire file into a string. In one shot, you get the entire file, or you can just use read line to read the next line. And conveniently, read line returns an empty string when EOF is reached versus a new line character if the line is blank. So you can actually distinguish between a blank line and EOF depending on whether the string is empty or has a new line at the end of it. Now, you typically don't go through it that way. Typically, you treat the file just like a list and read it like that. So you don't have to worry about the end of line. Another neat thing is you can just suck the entire file into a list using f.readlines. So that is very helpful. In fact, you should use this on problem 1 of your homework assignment, where you write a tail function to write the last n lines of a file. So the easy thing to do is suck the entire file into memory and then just print the last n lines. If you want to write to a file, the write command writes a string to a file, and only a string. So if you want to write an integer, you actually have to convert it to a string, which is a pain in the neck, but is the way that it is. But let's say you have a list and you want to write the whole list out. You don't have to say for line in lines write. You can just execute a join command. So what this is doing is taking a new line character and saying join all lines by appending a new line character to the end of each line. So this is a pretty cool way to write a list of lines to a file, or to take any array of lines and join them together into one string. Okay, if they already had new line characters, I could have used an empty string here, would have worked. Okay, so let's say instead that I want to write something more complicated, like a list or a hash table or a tuple to a file, but not a class. Classes are more complicated. You use something called serialization, which refers to the conversion of a complex object to a string representation that can be written to a file. So normally in Java or C, you can't dump an array or a hash table to a file. But you can do that in Python using the dump method from the JSON module. So we all know what JSON, do we know what JSON is? You may not. We have not covered JSON here. So JSON is a standard that is used a lot in web programming, and it has a conventional way to represent strings that look like lists or dictionaries. So it's very good with name value pairs like this or with lists. So with JSON, you can represent a number, a Boolean, a string, null, a list, or a dictionary. And you can dump any of that to a file. So here, I import JSON. My A consists of this array. X is this dictionary. So I create a list consisting of A, X, and 543. I do a dump of this list to a file. And let's just quickly show you what happens. So we will import JSON. What's happening? Okay, import JSON. A equals 345. B equals, well, let's just take this from here. And write list. And now we'll do a dump. And what did it not like? Did I do in the wrong order? Looks like I didn't open the file. Okay. Dump it, whoops. Dump it to the file, close the file, and let's have a look-see. So this is a JSON encoding, which you don't really have to worry about, but I can now load it back in using JSON.load file object, and it will load it back into my program. So now I should be able to say G equals open foo.txt. I should be able to say JSON.load. Is it just G? I think it's just G. Yep. And there it is. It gives me back a list consisting of 345, a hash table consisting of that, and a 543. So that is a way that you can write objects out to a file and then read them back in. We're not going to worry about writing out classes. There is a pickle module that allows you to serialize classes, but we're not going to worry about it in this class. So again, scripting languages want you to be able to write out data structures that are more complicated than just integers, well, than just primitive data types. And that ability to write out more complicated objects using a string encoding is called serialization. Okay, and then deserialization reverses the string encoding, recreates those complicated data structures in memory. Okay, so what I want you to do, just very quickly, see if you can, take a couple minutes. Probably don't, I'm going to slop over just a little, but I want to show you how to do things. So take a look at just this tail and see if you can just take a couple minutes, 2 or 3 minutes, to think about, or on a piece of paper or a program or something, write out how you would. Don't worry right now about even reading these things off the command line, which is what you have to do in the program. Assume you have hard-coded the number of lines you want to print and the name of the file. and just see if you can figure out a simple way to print this thing. The last n lines. Okay, so you may not have finished it, but you're liable not to do it in a super efficient way if you have not seen a very simple way. So I'm going to hard code n and the file name just to make things easy. Let's see. Actually, I need to find a file name here that's going to be sufficiently big. I will try savings. Try this one. So this hard coding. You in your assignment will have to actually take this off of the command line. So you have to do a little more work. But here's how easy it is. First, I'll just create a file that opens it up. So file name. And actually, I should use width. So width file name as F. And what I will do is read it into, I'll just say lines equals F dot read lines. So that will read my entire file. And now I will say print join lines. So, and I will use my subscripts and array slicing to do the trick. So what this does, it starts at negative n. So that's going to give me the last n lines of the file, colon, I don't terminate it. So it goes to the end of the file. The lines already have new line characters. So all I have to do is join them using the empty string and print. Of course, I need to remember, I'm still so used to Python 2. You have to put it in quotes. And that should do the trick. This this right here essentially implements tail n. And to prove it, you will write it out. And it didn't like the as f. So let's just check to see what I got wrong. Did I get wrong with that with statement? With open, Sure, I got that with statement right. With, nope. Okay, see if this works. There we go. So that worked. It printed the last 5 lines of the file. Just to show you a bit more, we'll print the last 10 lines of that file. There you go, the last 10 lines. So very simple tail program, but again, the with ensures I don't have to close the file. The read lines reads the entire file in one foul swoop. The print I achieve by printing out this slice using -n. I join them using this empty string, and that prints them out. So a very simple 3 lines gets my tail done. So with that, I will let you all go. On Tuesday, we're going to finish up Python with a discussion of modules and classes and a little bit of a hint for your other 2 questions on the homework assignment. So have a good weekend. I will see you Tuesday.